Hey all, this is Shon Gerber. Thanks for listening today. But before we get started, I have some great news for my listening audience. I'm getting ready to launch my brand new site, CISSP Cyber Training.com, here on March 1st, 2023. And it is going to be awesome. There is a new website being developed right now, and it will make your journey so much easier to get the information you need to help you pass the CISSP exam. As a result, I'll be offering a one-time, never-to-return price. Get it? A one-time, never-return price for my membership that's going to be incredibly valuable to anyone who signs up. I will only be offering this extremely valuable pricing one time. That's it. Not anymore. So if you're planning on taking the CISSP exam in 2023, this will be the time to make a life and career-altering decision for you and your family. So stay tuned. You will not be sorry that you did. All right, let's get started. Welcome to the CISSP Cyber Training Podcast, where we provide you the training and tools you need to pass the CISSP exam the first time. Hi, my name is Shon Gerber, and I'm your host for this action-packed, informative podcast. Join me each week as I provide the information you need to pass the CISSP exam and grow your cybersecurity knowledge. All right, let's get started. Hey y'all, it's Shon Gerber again with Reduce Cyber Risk, and I hope you're all having a beautiful day today. It's a gorgeous day here in Wichita, Kansas. It's just couldn't ask for anything better. So it's an awesome day in Wichita, Kansas. Well, today we have some great things that are going to be happening in the CISSP training field, and we're going to be talking today on our CISSP. Its security integration is going to be around Trusted Computing Base, otherwise known as the TCB. Our overall training is going to be on Domain 2, and we're going to be talking around managing engineering processes using secure design. And then finally, the CISSP exam question is going to be focusing on the CIA triangle and TPM, Trusted Platform Module, I think is what it is. Yeah, TPM. I think that's what it is. There's too many acronyms. Can't keep track of them all. But we'll get into that here in just a little bit. But before we do, I wanted to put a quick shout out about my CISSP training courses that are available for your purchase at udemy.com. And you can catch those up at Udemy. You also can go to reducecyberrisk.com/CISSP-training, and you can get access to the Udemy courses that I have available. I have put out there all of the CISSP courses. Domains 1 through 8 are all available for you to go get at Udemy. And as you well know, Udemy's bargain basement prices are actually pretty incredible. I mean, it's amazing what they offer from a pricing standpoint. But the cool part about all that is I will put updates to those on a routine basis. Each of those domains will be updated on a weekly basis based on the content that's put out. So it is a great place for you to go get your CISSP training to help you augment your studying for the CISSP exam. So go check it out at udemy.com or at reducecyberrisk.com/CISSP-training. All right, let's get going. Okay, in the CISSP cybersecurity integration, we're going to be talking about 3.2 fundamental concepts of security models. Now, how does this work? Well, basically what I end up doing is I take the ISC Squared training manual that they put out that goes over what you need to understand for the CISSP from ISC Squared, and I break it down into the different chapters and subdomains that they have. And so what I've done is out of 3.2, which basically focuses on the fundamental concepts of security models. These are the key aspects and data that you're going to need to understand for the CISSP exam. And the key concepts, the key understandings, and we will go over all of that with you here on Reduce Cyber Risk. Now, one of the key points to consider is that this is the foundation of creating secure code. And when you're trying to come up with, and I have a development team that works for me, so I deal with this on a routine basis as we're relating to development of code for my team and to protect our company. And this includes operating systems and associated security mechanisms. So it doesn't necessarily mean just the code that would go into a potential CMS. It also means the operating system code, which would be in, let's just say, XP, which is really, really old, but people still do it, or Windows 2008 server, or whatever it might be, it's SQL Server, whatever. The bottom line is that the operating system itself needs to have the level of security put into the actual development of the code. But this also that's a really good word. It also becomes around the hardware, the physical locations, the network, hardware, software, and the prescribed procedures. You need to really include secure coding in all that you do. Now, there's some key provisions you need to follow. Access, authorization of resources, user authentication, and the backup of the data. So there's some key concepts, and when it comes into the provisions, it's who has access, how do they have access, who has the correct authorizations for those specific resources, whether it's even an individual account or it's potentially a service account, something that's accessing it to just run the system. User authentication, and then also how do you back up the data and how is that data secured. All of those key pieces are fundamental when you're dealing with the concepts around security models. Now, TCB, the history around this came from a gentleman by the name of John Rushby. Depends how you sound it and how you say it. They call me Sean or Sean. Yeah. But see, my first name is Shon. See, it's just, I love it. It's just great. My parents did that to me. Hey, by the way, if you're a parent, don't do that to your children. Just don't do it. Just say no. Just don't call them Moonbeam or something like that. Just say, call them Bill or Fred. Those are always good names. Yeah, those are good names. All right, so I'm sorry, a little bit bitter. My friends call me Enrique. So if you don't know, you can call me Enrique. But basically, John Rushby defined TCB as a combination of a kernel and trusted processes. Now, what does this actually mean? This isn't kernel like a kernel of corn that you would get and you would grow out in your field or in your plot of land, but this is a kernel that's tied to the hardware. And then the software, these are trusted processes that run a level of software that runs as a trusted process on the kernel. Now, these are designed to be very, very small in size. And so therefore, as they're small in size, they can't be very big, right? Hence small in size. But they also have to be lightweight and be able to run very quickly and efficiently. And these are a set of controls that are designed to work together to form a trusted base, a base code to enforce a security policy on that kernel. Now, we talked about the different books that are available. I think we talked about that last week, but the Rainbow series, and it's the NSA version of that, and what they have, the different green, the blue, orange books, and so forth. Well, the orange book is a part of the Rainbow series, and it defines the TCB as this. It's the totality of protection mechanisms within it include hardware, firmware, and software, the combination of which is responsible for enforcing a computer security policy. Again, the policies they're not like a policy that you would make to go create a law. I mean, they kind of are, but they're not. It's basically the rules set up to govern how security is put in place on a specific system. So those are the policies. And you'll deal with policies in security policies that are within your company. As a CISSP or as a cybersecurity professional, you may end up putting some level of policies in place. And these are a written document that specify how things need to be taken care of. So there's those kind of policies as well. Now, the Orange Book defines that the boundaries of the TCB depend significantly on the definition of the security policy. Hence, that's what defines where they can get access and where they can't get access. So as an example, we'll use a web server. Now, this is a multi-user application, right? Web servers, lots of people log into them. Lots of people use them, from admins that log into them to the fact that there's just gobs of people hitting them from all over the world. It is not part of the OS's TCB, okay? So the web server itself is not part of that. Now, it provides access controls to prevent individuals from usurping other people's rights. So you can't be a squatter, go in there and kick somebody out. There are various access controls in place to prevent that from occurring. Now, a breach of the application, so of the web server application, whatever that might be, whatever you're using, would not constitute the breach of the OS's TCB. So it's the layer above the TCB, above the overall OS itself. So if you blow up the application, you get access to it, and you are God on the application, you do not necessarily have access to the OS's TCB. So as a TCB software protection, the Orange Book speaks of the TCB needing to be protected against tampering. Duh, right? You don't want someone to get access to that, because if they get access to your trusted computing base, they game over, they own it all. Okay, because that's kind of a problem, right? If you own the foundation, then you own everything that's tied to the foundation. And the TCB must prevent its own software from being written to. Now, they have the memory management unit. You might have been hearing about this in some of the trainings you've learned and some of the readings you've done, is an MMU. Okay, now in a previous life, an MMU was used as a mass measurement unit. I used it when I used to fly A7. I didn't fly those. I actually worked on them. A7 Corsairs. That just shows how old I am. I'm like dirt old. But these MMUs, that's to digress, they used to work in the navigation. But the memory management unit that's on a computer adds protections to protect your TCB. Now, it's programmable by the operating system, so it denies access to specific ranges of systems memory requiring to be run, so that it actually provides it will provide a capability or it'll remove the capability depending upon what's going to occur. And then, of course, there's got to be God mode. But this is supervisor mode, which allows for and restricts this access. So the supervisor mode allows you to do that with the operating system. So again, the TCB software has a lot of protections in place just to protect it from knuckleheads like myself that would go poke around and get into areas they probably should not be getting into. Okay, that is the TCB software protection, and we are TCB, I should say. And so we are going to move on to the CISSP training. Okay, so as we're dealing with CISSP Domain 3, Security Architecture and Engineering, the topic du jour is going to be implement and manage engineering processes using secure design. All right, so we talked about the TCB from a Wikipedia concept. Now we're going to talk about some more things that would be detailed out in the CISSP. So we talked about as far as the TCP and how it's considered at all stages of system development. It's how important it is that you need to consider its use. Programmers should also strive for secure development. And this is when you come down to developing from a firmware to the OS model, the OS, all the way up to the application. You should strive for secure development. And this would be, you'll see terms out there. I've seen them just as DLC, which is just basically software development lifecycle, and security is kind of weaved in there. I've also seen SSDLC, which is your secure software development lifecycle. So it kind of goes hand in hand. I would say that the security, when you're calling that out specifically, obviously that defines security more than being just software. However, if you're going to be doing SDLC, one of the questions I ask any potential new developer is how do they interweave security within the SDLC? Because they'll throw out that as a big buzzword going, software development lifecycle, you need to do it. Or I do it right now and I'm pretty awesome. And then what I ask, okay, so how do you do that from a security standpoint? I mean, do you incorporate some level of security within your SDLC? So something there to consider. And so therefore, when you talk about this stuff, it's important that there are some key security items for security design that you need to consider. Now we're going to get into objects and subjects. So an object is a resource used by a subject, which would also be a computer system. So your object could be a computer system, a defined system that you're going to be working on. Subjects are user or processors requesting access, such as an individual or an RPA, which would be a robot process algorithm. Okay, those are RPAs. And so those are different things that are put in place, your object and your subject. Now there's a trust. These trusts are set up between objects and subjects. So as an example, you would have service accounts that would be a user, okay? And then you have an R&D computer, which would be an object. And these service accounts have access to this object, and therefore they can manipulate and go back and forth. However, the bad guys, the hackers, the attackers, they will then manipulate this trust between the objects and the subjects. So therefore, it's important that you have proper protections in place to minimize the attackers from getting them. Now, living in a previous life, a service account, I've talked about this before on Reduce Cyber Risk, is that it is the granddaddy dog that they want to go after. Typically, service accounts are set up that they're 24/7. They have very limited protections. Passwords probably don't change a whole lot, and so therefore they are the ones that are used to manipulate other objects and to just take advantage of them. So again, if you're CISSP and you're studying for this, this is the key. And this is what separates Reduce Cyber Risk from a lot of other people that are teaching CISSP. We got gobs of experience on this stuff, and we've seen a little bit of it. Now, believe me, I know I got a lot more to learn, tons more to learn. But those things are definitely leveraged. And so just understanding the test and passing the test is the first piece of this. But the ongoing and understanding how these accounts are leveraged, yeah, that's the ongoing aspect that you got to be aware of. Now, there's closed and open systems. A closed system is designed to work with a very narrow range. Okay, so it's just designed in a certain area. Again, I've dealt with this in the past from a military technology standpoint. Those were closed systems, and they are defined typically by the manufacturer. So let's say you have a stealth fighter, and you have a specific system that needs to be working on that stealth fighter. They will have that as a closed system. It's not updates, all that stuff. It doesn't reach out to the internet and get, hey, I'm going to get an update. It doesn't do any of that. You have very close parameters on how the updates occur. They are sent specifically to individuals to update themselves. They're trying to avoid as many inputs from the outside that would be random and that could potentially add to a vector into the system itself. Again, so these are defined by the manufacturer. They can be more secure. They really can, sort of. And what I mean by that is the fact that because they are a closed system, they are segregated away. And the downside of that is, and you see this even in the manufacturing space, when you have a manufacturing system that is separated, such as using the Purdue model, what will happen is in many cases, these systems that are maybe blocked off by firewalls do not get updated as routinely as they potentially should. So therefore, they are a bit more susceptible to vulnerabilities. And so that's why it's important that I say sort of. You need to make sure that if you do have a closed system within your environment, you do make sure that you do update it as much as you possibly can. Now, open systems, these are agreed upon an industry standard, and these are much easier to integrate with other systems, i.e. because they have a standard and they're updated on a routine basis. We used to call this COTS, which is what I used to. They think they still do. It's Common Off-the-Shelf Software and Systems. I think that's what the acronym stood for. Basically, it's stuff you could go buy off the shelf and shove it in a plane. COTS is an important aspect. Now, the problem with COTS was it was not as tested as these the systems that are defined specifically for an aircraft or for the military, but they are getting more and more integrated within the military system as well. There are more options to these networks as far as with being an open system, but they are less secure. And as they are less secure, you have to be aware of that. So again, an example of that would be a current computer system that you can get. You can go buy a new laptop, desktop. Desktops are really kind of hard to get right anymore, but I mean, you can buy them obviously, but they're not nearly as prolific as they used to be. But you go get these new current computer systems, and they are built to a standard. They integrate well with others. They play well with others, but yet they don't really have they run the risk of being a little less secure because they have so many bells and whistles that have to be in place. Now, techniques to maintain confidentiality, integrity, and availability. We're going to get into confinement. Okay, so this is various techniques that are created by software developers. And any of the following can be used outside of software development. It doesn't have to be specifically in the software development world, but it's where we're talking about right now. But bottom line is confinement. So what does that mean? It restricts user. Yes, that makes sense. The word says confine, restrict users and process access or actions to a program. It also allows a process to read-write from specific locations. So it confines it to what it can do, where it can read. It defines who can access it, what programs can access it. So again, it confines the restriction. It puts restrictions on it. A sandbox is a place to restrict where you can operate. Again, now this is also a place where cats go poo, but we're not talking about that sandbox. We're talking about a different sandbox. This is one where you place restrictions on where you can operate. You can play in. It's a place you can play and be protected from the bad guys out there outside of the sandbox. That's the purpose of it. But you must meet and operate with a higher level of security in the sandbox. Now, I've seen it with other companies. FireEye, many others will do this. They will have a sandbox in place where a piece of malware will come in. It'll go dumped into the sandbox, and it'll be run to see if it implodes. If it doesn't implode, then it will be moved on. Now, the bad guys have figured out how to get around that, obviously. They just put timers on things and so forth so that when it blows it up in the sandbox, hey, it works, no big deal. And then it moves it on, and then it blows up and does bad things. But the sandbox is a place where things can go nasty, and you don't care, except for when their cats go in there and use it as a litter box. That's usually not so good. Anyway, but moving on. Example is only specified systems can operate against a specific database. Any systems outside the scope are not allowed. So again, if you're a very specific system, it can operate on that database. It can operate in the sandbox, but nobody else is allowed out inside the sandbox that is not supposed to be there. No children from other places. Now, bounds and process isolation. What does this mean? Well, bounds are defined processes that are given authority to operate. They can be many or few. So again, the processes that are in place, you define these bounds, right? Now, obviously, more is not necessarily better, especially as you're dealing with the kernel and other things. But one of the aspects around this is the user, the kernel, and the administrator. These are specific processes that are given access and authority to operate, but you have to create these bounds to define what they can and cannot do. The operating system, memory, and hardware, these are processes that would be defined, bounds defined, right? Your operating system, this system can use, or this user can use this. Memory, this one can do it in hardware. Typically, the kernel can do it in almost all those places. It should be able to do it in all those places. So those are aspects that you're going to have to, that will be defined for you in most situations. Now, an example, malware will utilize errors in these bound settings, and then it will go and start mucking with stuff. An example would be kernel manipulation. So if your bounds are not set correctly to deal with the kernel, and you have users that can get access to the kernel, then it will go and flag. They'll be able to mess with it. And if they mess with it, and they mess with the kernel, as we talked about in TCB, they will own everything. Now, the key around all that, though, is that if you have a product such as EDR, which would be endpoint detection and response, or response, that would nodalize. That's not really a good word. It would utilize or understand if someone was to manipulate the kernel and then trigger on that. So again, that's why these endpoint detection products are really, really valuable. Now, process isolation, this ensures that only affected specific memory locations, or only specific memory locations are affected, and it's an essential part of a stable system. If you don't get into process isolation, what will happen is then all these processes will run all kinds of goofy stuff, and then it'll crash and cause you all kinds of issues. Now, it also prevents applications from accessing memory from other locations. Cut, paste, copy. All of these will be allowed to transition. And so therefore, it's important that as you're dealing with process isolation, that you do make this piece very limited. As an example, you got cut, paste, and copy. Those are processes that would be isolated. If you don't do that, then you can use these functions in many other ways, and hackers can utilize them outside of their parameters, and then that would be bad. And they will try that. They try everything. And then another way would be macros. These can run outside of defined parameters. And then you get all kinds of manipulation occurring of these macros by hackers or attackers that are causing effects to your environment. Okay, that's all I have for CISSP training. Let's get into those exam questions. All right, CISSP exam questions, domain 3. All right, so this question is going to be talking a little bit about confidentiality, integrity, and availability. All right, so Fred recently received an email from Bill. So Bill got an email from Fred saying, "Hey, you're awesome. I like you. You like me. Yeah, we're good. Let's go out and do some fishing and go have barbecue." No, that's not what he said, but that's what I just ad-libbed. No, Fred recently received an email from Bill in his inbox. What goal would need to be achieved to ensure Fred that the email is legitimate and it has not been spoofed? We got confidentiality, non-repudiation, integrity, availability, or one of those 3, 4, 5, one of the 4. Okay, A, B, C, or D. So A is confidentiality, B is non-repudiation, C is integrity, D is availability. The answer is B. Non-repudiation does not allow the sender to transmit a message and then to deny that it was sent by them. So that's B. And so yeah, I kind of fibbed to you guys. It wasn't about CIA. It was actually about non-repudiation. So gotcha. Bottom line though is non-repudiation is the goal. So you want to be able to repudiate. So if someone says, "It wasn't me, I didn't do it," that's repudiation. So non-repudiation would be the negative of that. That does not allow the sender to transmit the message and then deny it was them. And so that's what you also want to do from maintaining your systems, is you want to have the availability for non-repudiation from a hacker. Hence, you have logs that are locked down that people can't get access to. You want to have the ability to basically be able to restrict people from getting access to systems that they don't need to get access to. Now, next question. What is the following as it relates to the trusted platform module? Which of these, as it relates to them, is true? A. The TPM installed within hardware is much slower than the software variant. B. The TPM does not store the crypto keys for the system. C. The TPM is responsible for storing and processing the crypto keys for the system and can be in software and hardware systems. D. All of the above. Okay. And the answer is C. The TPM's sole purpose is considered the trusted source within the computing system and will store and process cryptographic security keys. Full disk encryption will store the encryption keys in this location. Now, I didn't go over this in the TPM, but it does do that. The Trusted Platform module will go over and deal with the encryption and crypto keys, and it will store them for you. So we'll talk about that in another domain or another podcast, but it's basically that is the domain of domain 3. You would be dealing with the TPM. So again, the TPM is responsible for storing and processing the crypto keys for a system and can be in software and hardware systems. Hardware like firewalls and switches and stuff like that. Okay, software like your software.
Thanks so much for joining me today on my podcast. If you like what you heard, please leave a review on iTunes, as I would greatly appreciate your feedback. Also, check out my videos that are on YouTube. Just head to my channel, CISSP Cyber Training, and you will find a plethora of content to help you pass the CISSP exam the first time. Lastly, head to CISSPCybertraining.com and look for the free stuff that is only available to our email subscribers. Thanks again for listening. See you.